Today we're going to talk about converting from one unit to another. And we're going to start by doing some conversions with the American system of measurement. So I have a list of some conversion factors that you don't need to memorize. In fact, in D2L in this module, I have a list of all of the different conversion factors that might come up. That particular list is something that you'll be given when you take exams on this topic. And so let's just start by doing an example. We're going to be using something called dimensional analysis to convert units. So what that means is we're going to start by writing down the number that is given to us. So if I want to convert 100 inches into feet, I write down that 100 inches as a fraction over 1. And then I'm going to take that number and I'm going to multiply it by a rate, or a ratio, that contains a conversion factor. So I know that 1 foot is 12 inches. I need the math to work out with the units. And so I'm going to have to put the inches on the bottom and the foot on the top, because we can actually do math with units. If the inches is on the bottom, then it will cancel with this inches on the top, and we will be left with feet, which is what we wanted. So I'm going to fill in the numbers. The factor says 1 foot is 12 inches. And then I'm going to multiply straight across, and that gives me 100 over 12 feet. Or if I reduce, I can divide by 4. I get 25 thirds. Or as a mixed number, 8 1/3 feet. So 100 inches is the same as 8 1/3 feet. So the idea is you have to really keep track of those units and make sure that they will cancel out, the old units cancel out, and you're left with the new units. So let's try example B. We're going to do miles to feet. And so here's my conversion factor. 1 mile is 5280 feet. So I'm going to start by writing down the 0.25 miles over 1. And then I'm going to multiply by a conversion factor, and I have to put the miles on the bottom because now the miles will cancel out. The factor was 1 mile is 5280 feet. And so I'm going to multiply my 5280 times 0.25. So I do the multiplication, and I end up getting 1,320 feet. And that's my solution. Now in example C, we are going to take something with an area unit. Square feet is the units that we would measure area in. That unit square feet, you can actually write it with an exponent as feet squared. But what that actually means is you are taking units of feet times unit of feet. So we can set this up the same way. We've got 4 square feet over 1. And I want to convert this into another area unit, square inches. So at first you might think, well, we could use that conversion factor from earlier, that 12 inches is 1 foot. But this isn't completely right, or halfway there, because we only have 1 foot, and that's only going to cancel out with one of these feet. So what we're going to do with area conversions is we are going to multiply by the exact same conversion factor twice. We'll always do this with these square units. Because now I have feet, and that's going to cancel out with my square feet. Notice I'm left with inches and inches. Inches times inches is square inches, and that's exactly what I want here. So for area conversions, you have to multiply by the conversion factor twice. Let's see, 12 times 12 is 144, so I'm just going to do 144 times 4, and that gives me 576 square inches. Now sometimes you might have to do the conversion in multiple steps. So if I want to convert 3/4 of a gallon, well, first of all, instead of writing it as 3/4 over 1, feel free to just write it as 3 over 4. You can put that 4 in the denominator instead of the 1. Now, ideally, I would have a conversion factor with gallons to cups, and I would put gallons on the bottom, cups on the top. However, if you scroll back to the top of the page here, my conversion factors are 1 gallon equals 4 quarts. I don't have gallons to cups. And 1 quart is 2 pints. And then finally, 1 pint is 2 cups. So in this case, I'm going to have to use multiple conversion factors to get where I want to be. So I'll start with the conversion factor with the gallons. 1 gallon is 4 quarts. The gallons cancel, and I'm left with quarts. Then I'm going to use my conversion factor. 1 quart is 2 pints. The quarts cancel. I'm left with pints. I'm almost there. Finally, I'll write down my conversion factor. 1 pint is 2 cups. The pints cancel, and finally, I'm left with the units I want. So I'm going to multiply straight across. 3 times 4 is 12, times 2 is 24, times 2 is 48. And then in the denominator, I have a 4 times 1 times 1 times 1. And 48 divided by 4 is 12. And so my answer is 3/4 of a gallon is 12 cups. So sometimes you might have to multiply by more than one conversion factor. The idea is just keep track of those units. Make sure that the things you don't want are canceling out, and you're left with those units that you do want. Finally, before we move on to the metric system, let's take a look at one application problem. This problem involves area. We have a room that measures 20 feet by 15 feet, and we want to know how much will it cost to carpet the room. So we're talking about laying carpet on the inside of that room. The carpet goes in the area of the room, the inside of the room. And we know that the carpet is $15 per square yard. So the very first thing I would do in this problem, because we're talking about the inside of the shape, that's the area of the shape, is I would start by computing the area of this room. Area of a rectangle is length times width, and so 20 times 15 is 300, and the units of area are always square units. That's 300 square feet. Now, I want to know the cost of laying down carpet, and here's where the conversion comes into play. My cost is given in terms of square yards. So I need to change these square feet into square yards. And so I'm going to use that technique that we learned earlier. I'll write down the 300 square feet over 1. And because it's square units or area units, I have to multiply by the same conversion factor twice. The conversion factor I'm going to use is the fact that 3 feet equals 1 yard. Again, I'm multiplying by the exact same thing twice because then it takes both of those feet to cancel out the square feet. And then I'm left with yards times yards, which is square yards. So if I multiply straight across, I end up getting 300 over 9, or 100/3 square yards. I could write this as a mixed number, but because I'm not done with the math, I'm going to hold off on that. To finish the problem, if this is my area, 100/3, and I want to figure out how much is it going to cost to carpet it, I can take that $15 per square yard. Notice that the square yards will cancel and you're left with the 15, or you're left with dollars. So I have to multiply the area times the cost to get the cost of carpeting that room. I can go straight across, although I notice there's a common factor of 3. 15 divided by 3 is 5. And then if I go straight across, I just get 500 over 1, or $500 to carpet that room. Now, metric system conversions can be done in a very similar way, although it turns out all of the metric system conversion factors are multiples of 10. And anytime you multiply by a power of 10, what ends up happening is you just end up moving the decimal. And so I've got a little trick to show you about how we can do some conversions in this metric system. In the metric system, prefixes are used in measurement to describe the different units. So rather than using things like inches and then feet, distances are measured in kilometers, meters, centimeters, where the first thing in the unit is the prefix, and then the base unit might be things like meters, liters for capacity, or grams for weight. So if you want to do the conversion, you can just write up these prefixes in order from largest to smallest, just like I have on the sheet and I have done here. And so let's look at an example. If I want to convert centimeters to millimeters, the prefix is the C, the first thing, and the M. So I'm going centimeters to millimeters. Notice that in my list, I have to move over to the right one to get from centimeters to millimeters. So we can actually do the exact same thing with the decimal. I'm going to take the decimal, move it to the right one, and that gives me 457 millimeters. In my second example, we're going from millimeters to meters. This is a base unit. There's no prefix. So we're starting at millimeters. We want to move 1, 2, 3 to the left to get to that base unit. So I can take the 125, the decimal is at the end of that number, and move it 1, 2, 3 places to the left, and my answer is 0.125 meters. Now this only works because in the metric system, all of the unit conversions are powers of 10. That's why we can just move the decimal. Unfortunately, if we're going between the American and the metric system, we don't have powers of 10. We're going to have to do these problems the same way we did the earlier problems in this example, using that dimensional analysis. So if I want to convert 45 inches into meters, I would start by just writing down that 45 inches over 1. Now the first conversion factor I have listed is the only one with inches. I have to put the inches in the bottom so that it'll cancel out, and then I'm going to be left with centimeters. So I'm going to take the time to figure out what is 2.54 times 45, and I end up getting 114.3, and this is centimeters. Now I want the answer to be in meters, and so I'm going to go back to that list of prefixes. So we are starting at centimeters, we want to get to meters, so we have to move 1, 2 places to the left. So I'm going to move that decimal 2 places to the left, and I get 1.143 meters. So sometimes you might have to use a combination of the methods, depending on what kinds of conversion factors are given to you. All right, let's do one more example of moving between the American and the metric system. So I want to convert 140 pounds into kilograms. Here's my conversion factor. 1 kilogram is 2.2 pounds. So I have to put the pounds on the bottom and the kilogram on the top. If I multiply straight across, I get 140 divided by 2.2. And so I'm actually going to have to do this division. To divide by something with a decimal, we want to clear the decimal. I have to move it 1 place to the right. And so I have to do the same thing on the top. I'm going to move that decimal 1 place to the right. And I'm left with 1,400 divided by 22. I'm going to reduce to help me with the division. Both of these numbers are divisible by 2. And I get 700 over 11. And now I'm actually going to do that division. 11 goes into 76 times with a remainder of 4. 11 goes into 43 times with a remainder of 7. And then we have some choices. You could stop and write your answer as a mixed number. It would be 63 and 7/11 kilograms. Or if you want to add a decimal and keep going, you are welcome to do that. You'd bring down the 0. And what's happening is the 63s are going to repeat themselves. So you could write this as 63.63, and you could put a bar over both the 6 and the 3 to indicate that those digits are repeating. Now there's one last type of conversion I want to show you, and that's temperature units. The units are Fahrenheit and Celsius. And with temperature, we actually have formulas. We use formulas to do the conversion. So if I want to go from 22 degrees Fahrenheit into degrees Celsius, I'm trying to find degrees Celsius or find C. So I'm going to use this bottom equation. This is the one that's solved for C. C equals. So I'm going to plug 22 in for F. So I just take the formula, I replace the F with 22, and then I can use order of operations to do the math. I would work inside the parentheses first. 22 minus 32 is negative 10. That's like a negative 10 over 1. And then we could multiply straight across. That gives me negative 50 over 9. I'm going to write that as a mixed number. 9 goes into 50 4 times with a remainder of 5. And so I'm going to write that as negative 4 and 5/9 degrees Celsius. You could also write this with a decimal. You'd have to actually do the long division then. And you do not need to memorize these formulas. They're also on that sheet that you'll be given. If you want to convert into Fahrenheit, you can use that top formula that says F equals 9/5 C plus 32. So we're solving for F, so I use the top formula. I'm going to take 30 and I'm going to plug that in for C. Order of operations says we multiply before we add. So 9/5 times 30, well, there's a common factor of 5. And 9 times 6 is 54. 54 plus 32 is 86. 30 degrees Celsius is 86 degrees Fahrenheit.